So welcome to the AnyLogic workshop. There'll be two of us driving you through extensive AnyLogic 9 experience. Nikolay Churkov, obviously everybody knows this guy, principal software engineer at AnyLogic, has been with us basically forever. And myself, I'm Andrei Borshchev, CEO at AnyLogic. Now, this is AnyLogic 9 workshop. What is AnyLogic 9 for us and for you guys, for everybody? For us, first, it's the biggest development effort of all time. We virtually doubled our company to do it. And the biggest investment. For everybody, we're moving the last piece of our ecosystem to a new technology stack, where AnyLogic 9, which is basically the model development environment, will integrate with AnyLogic Cloud, also known as Model Manager. Model Manager is the term invented in AnyLogic North America. All right, so I'll use it. I'll be using it from time to time here. Now, we all know, and you know because many of you have listened to my presentations at previous conferences, that AnyLogic 9 is progressing slower than we wanted. That is true. However, our roadmap stays the same. The reason it is slower is just because in the beginning we didn't realize the amount of things we put into AnyLogic throughout 20 years. So in a way, right now we're developing, let's say, Adobe Illustrator and IntelliJ or JetBrains IDEA together as a web application. This is what we're busy with. But we've made a good progress, and today, instead of presenting you with a roadmap and here where our progress, we want you to try AnyLogic 9 out. And this will be a very intensive, like massive modeling exercise. Now, the topic, as you can see, is about beer. And my original idea was that as you are doing your AnyLogic 9 model, there will be these two beer brands on your tables. However, conference organizers rejected my idea. All right, but that's sad, of course. But the good news is that after you have successfully completed the exercise, there'll be a cocktail hour in the room behind, and then the reception. All right, so with that said, your options. Option one is you stay in sync with us and basically do same on your laptops. That'll be challenging because, as I said, it's a lot to do, and we will be going pretty fast to make it fit in 1 hour. Now, if for some reason you fall behind, there are two more options. Option one is you have handouts and with pretty detailed steps of what you need to do. And you can use those and go at your comfortable speed. Or you always have an option of sit back, relax, and watch other people work. All right, so
some prerequisites, because AnyLogic 9 is online tool here, you need an internet connection. So please be sure you have it. And you could also download this PDF file by this link. Just make sure you have enough place on your table to use this if you want.
Yeah, so that's this link is the same file as your handouts. And it might be useful if you want to copy some code fragments from PDF directly to the software. Okay. All right. So problem specification. So you're running a pub, simplest possible pub. You have a square room with one counter, and these are the two placeholders for the beer kegs. And beer is draft beer sold from kegs. Each keg is 20 liter. Now, beer drinkers come in with a rate 20 beer drinkers per hour. They can only buy beer at the counter, and they only buy beer in pints. And just for your information, 1 pint is 0.473 liters. Now, some timing. This is how much it takes to fill the pints, and this is the rate basically, or filling a glass. Then, on average, is 1 minute to pay and 10 minutes to drink. As simple as that. Now, bartenders are here behind the counter, and they serve customers. After drinking a pint, there is a choice. As in the real pub. So with a 40% probability you leave, with a 60% probability you stay for another pint. Okay, and we will have some unhappy customers. So if within 5 minutes I cannot attract attention of a bartender, I leave angry. Okay? Now, from the very beginning, I will tell you that you will not be able to do both beer brands within this 1 hour. Therefore, please, for now, disregard this part of the problem definition, which is below the floor plan, and which is about when you drink Corona and when you switch to Dos Equis, etc. We will only be able to do Corona, because it starts with a lighter beer. Okay? Now, questions you need to answer. First, how many bartenders do you need to keep everyone happy? They have 0 unhappy customers. And question number 2, how much Corona do you need in stock to keep going for 5 hours? So this is the problem specification. And we will be, as always, in simulation modeling, we will be solving the problem iteratively in phases. And these are suggested phases, like very simplistic beer drinkers flow, adding bartenders, adding the beer flow, more complicated and more realistic beer drinkers behavior, and then going to the cloud and do some simulation variation experiments in the cloud. Well, everything will be in the cloud, of course, but I actually mean that switching from the editor to the model manager. Let's put it this way. Now, there's optional part and there's homework part. Why homework? Just because your AnyLogic Cloud subscription will remain valid for 1 month. So you will be able to play with AnyLogic 9 after the conference. Okay, so I'll close my presentation and I switch to the browser. This is obviously Chrome browser. I am already logged in as a subscriber. You see the star over here? That means that I'm a subscriber. And AnyLogic 9, the model development environment, the model editor, is only available to subscribers. Now, At this time, I would ask everybody to log in using your credentials, which are on the back of your handout, like this. So go to cloud.anylogic.com and log in. So I'm already logged in, so I won't be doing that. Now, I assume that those who want to work with us now are already logged in. So the first thing that I'll do, I'll switch from the public models to my models. Okay? And there, in my models, you probably have the empty workspace. I have a lot of them. But nevertheless, everybody should have this new model tile. So I'll press new model, and the name of my new model will be as simple as pub. Oh. And this is AnyLogic 9. This is the model editor. It should not be too unfamiliar for you. What do we have here? Obviously, we have the canvas, and if I hold down my right mouse button, I can drag the canvas, can do panning, just the same as in AnyLogic 8. Here on the left, I have palette with libraries, and for now, libraries available for you are process modeling, pedestrian, and fluid, and these are some other palettes like presentation, analysis, etc. Now, you may wonder, where is the project structure view? It's here. So you can, right now, obviously, I only have the model pub and the main agent, nothing else. So I'll hide it. Here on the right are, just as in the AnyLogic 8, there are properties. Okay, so we will start with the pub floor plan, and we will doing some space markup over the floor plan. So what I would ask you to do is, if I go here, I would ask you to download this pubfloorplan.png. So you can go to your PDF and just click on this link. And then save image as. I already have it saved. So please do that. And hopefully, if you have this image downloaded, I will proceed with the floor plan. So first, I switch to the presentation palette, to this one, and I drag the image onto the canvas. Here, I mean, I'm already in downloads folder, and I have this image in here. If you're not, then you need to navigate here to downloads folder and find the image you just downloaded. Okay, here it is, and I move this image to the coordinate origin. So it's here. And in the properties, I'll lock the image. Click this lock thing to make sure because I will be drawing on top of the image, so I don't want this image to be occasionally selected. So I lock the image, and now I cannot select it with the mouse unless I click here. Okay, now. So
now we can switch to full screen. Here, because it's Chrome browser, it allows us to switch to full screen because we will be drawing something on the canvas.
Yeah, cool. That's a good idea. So what I'll do, I'll press F11, but I'm using Windows. On Mac, this should be something else. And now I have full screen Chrome browser application. Now, the other thing, is that we already can enjoy some nice accessibility features of a web app. For example, if I want everything to be bigger, I just can, like, let's say, place my mouse here, and with a mouse wheel, I can adjust the scale. For example, I want to do like 110% scale. Should be good for this workshop. And if my mouse is over the canvas, if I do the same thing, Control wheel, then I'm scaling the canvas and changing the zoom in and zoom out. Okay, and you can see the scale over here. All right. So let me stay with 200% zoom, and I'll create the floor. Pop floor markup. Please go to pedestrian library and start with the outside wall. So I click on the outside wall, and then I start drawing it. First click, and then if I hold Shift key, then it'll be a line either horizontal or vertical. Click. Next click, another one, and double click to finish. Did it create? Okay. Yeah, it did. I'll make the wall thicker, like this. Now, this is obviously a polyline. If our pop had some curved segments, we would be using the guidelines like this, but we don't need that at the moment. It's it's very square pop. Okay. Now, next thing is this counter. So for that, I will use a rectangular wall, this one, and create a rectangle here. It can touch the outside wall, or you can leave the space, doesn't matter. This counter will have a name, and name is specified here in the properties. Counter. And one more thing I want to change here is the Z height. So the Z height here should be 10 to make the counter lower than the walls. Okay. And the reason I need the name is obviously because I will be referring this markup from my flowchart. Okay, and two other items, two target lines, one here at the entrance, and I'll just call it entrance, and another one near the bar. This is where the beer drinkers will be calling bartenders and drinking beer, paying for the beer. So this line also needs a name, so I'll call it line counter. Okay. That is it with our simplistic markup, and I'll go back to 100% zoom. For that, we have a shortcut. So if you click here at the scale, one click goes to 100% scale, double click also brings you to the coordinate region. So if you are like lost somewhere and don't know where you are, you can always double click here, and that brings you back to the coordinate region. Next step is the simplistic flow chart. So I'll stay within the same pedestrian library palette, and I will, of course, start with the pedestrian source. So our beer drinkers will be coming in, then they will be going to the counter. So I'm dragging the next block. If we drag it aligned to the previous block, if the port aligns, then the connector is automatically created. Now, after going to the counter, let's say in the simplistic version, our guests will just drink, and that will be modeled by a delay block, which can be found in the process modeling library. So I go here, and I'll drag the delay block, like this. For example, the block did not connect, and if it did not connect, I can connect it by clicking here and clicking at the other port. And there's automatic alignment of connectors. Okay, I will rename this block to drink, let's say. I can do it right away here, or I can do it later. Okay, drink, then back to the pedestrian library. Leave the bar, and pedestrian sync. This is...
Yeah, we could also rename these go-to blocks in case we have several of them.
Yeah, let's do that. So let's name this one. So I select the block, and I can double-click here to rename it to counter. And this one, the name is
to exit.
exits. Very good. I can do it here, like to exit. Good. Well, hope you were. I cannot see anything, but I hope you're somewhere at the same phase. All right. Next, we want obviously to parameterize our flow. So I click at pedestrian source. What do we need to specify here? Obviously, where pedestrians appear in the model. So this is my target line, and it already signals me that I need, this is a required parameter. So I click here at select, and it suggests that I can either choose entrance or line counter. I will choose entrance from this list. Okay, now what else? We know that the rate is not 1,000 but 200 per hour, so I change this to 200 per hour. And I want not the generic agent, but I will create a beer drinker. Create new agent type, beer drinker. And I will leave the default animation, which is person, and I click finish. Anything else at the pet source block?
That's it?
That's it? Yeah, all right. All right, next one, to counter. This one is very simple. I only need to specify that from the entrance, the guests go to the counter. So as a target line here, I select line counter. Drink. You remember that on average, it takes 10 minutes to drink a pint. I will leave that default triangular distribution here, but I will change the parameters for 5, 10, and 15, and I'll specify minutes, not seconds. So on average, that'll be, and also most frequent beer, pint drinking time is 10 minutes. Now, important thing, this is by default, this guy, this delay block, will only let one entity in there. And that's not what I want, because I want many, as many as I want for the time being, guests to drink simultaneously. Therefore, I will check this maximum capacity. You can change it to anything, and you can also use, it's up to you entirely. You can use code completion, by the way. Okay, we're done with the drink block, right?
Yeah.
Yeah, okay. And the last one, to exit, also simple. The target line is obviously the entrance, which is, of course, entrance and exit. That is it with the flow chart, the first version of my flow chart. Now, the next thing, before running the model, I want to do a couple things more. First, I will add 3D window right away, so I switch to this presentation palette again, and I'll drag the 3D window over here. Just leave the default size. It'll stay on the upper right corner of my my window, and this blue rectangle is the default size of the presentation window. Now, one more thing. I will go to the model properties. So I will expand the projects palette, this one, and I will select the top level item, which is my pub model. On the right, you can see the properties of the model. Okay, that like the name, the top level agent, memory. I don't want to touch these, but I want to things happen a little bit faster in my model. Therefore, my default time units will not be seconds, but minutes. Okay, and if you remember, the pub is we're exploring the pub operation during 5 hours. Therefore, I will set the stop time not to 1,000 minutes, but 300 minutes, which is, of course, 1 hour. And anything else, Nikolay?
That's it.
Should be it. Okay. I will close the projects view because I don't need it at the moment, and I will run the model. How to run the model? You see this run icon here. So if I press it now, I will not exit the editor, but I will have model animation running on top of the editor. Right now, it's building the model. So what goes on at the back end, the model gets, the code is generated, the model gets compiled, and it is run in AnyLogic Cloud. I can do another full screen. So, well, looks like everything is as expected. So people come in, drink, and go away. What else? Yeah, you can navigate the 3D window just using the same keys as in AnyLogic 8. Here, panning is left drag, left button down, and then drag, if you don't remember that. Now, one of the frequent mistakes is if somebody forgets to specify the maximum capacity at this delay block, then you will only see one customer here drinking. And if you see that, then go back to your editor and do the maximum capacity. Okay, so that was the first successful run. Hope you're getting similar behavior on your computers. Phase 2, adding bartenders. Okay, I will zoom out a little bit and I will select this whole flow chart and move it down just to have more space. Okay, and again, click here, brings you back to 100% zoom. Next, I will create the home location for my bartenders. It will be in between logos of Corona and Dos Equis. Here, I go to I can go to either one. I can go to process modeling palette and choose rectangular node, this one, and draw just a simple node here and rename it to node Bartenders.
So we are going to reference this node from the flowchart logic.
Yeah, that's why we need this, we need a name. Oops. All right.
Connection.
Okay.
I'm holding the cable.
Yeah, please don't touch anything. I touched something, I don't know. So, okay, hopefully we created this, this rectangular node. Next thing, because we don't know the number of bartenders, and this is one of our tasks to find out how many, I will make it a parameter. So I go to this basic elements palette and drag parameter to here. This parameter will be number. Bartenders. Type is, of course, integer, and default value is 8. We will start our exploring this pub with 8 pub operation with 8 bartenders. Next, the actual resource pool block. Back to process modeling, find resource pool in here, drag it somewhere, let's say, nearby the parameter. I will rename resource pool right here, so as simple as bartenders. Okay, select this block. All right, capacity. Okay, it's not 1, it's not 8. Remember, this is a parameter. And here, it's for me, maybe you did it already, but in my case, I will use the code completion for the first time. So what I'll do, in my case, I'll type a couple letters, and then I press Control Space. I'm using Windows. Again, on Mac, this is something different. I never remember what it is. So these are the choices that code completion suggests. I can continue typing, or I can just choose this is the first item, and this is exactly what I need, number of bartenders. So this is how code completion works. So basically, it makes a request to the server, and server comes back with some suggestion. Other parameters of this block. Once again, I will create a new agent type, in this case, bartender. This is, for now, purely to get some nicer animation. And I will change the default person to something else. We don't have a standard bartender, I'm sorry, in this palette, so I'll use, okay, technician. Finish. So what we have specified there, okay, capacity and the new resource unit, which is our new new agent type. By the way, at any time you can check what agent types you have by expanding this projects view. We have main, of course, beer drinker, and the bartender. All right. Speed. Okay. I only moved to the United States from Europe. 7 months ago. So I'm still used to normal and good metric system. Therefore, I'll specify 5 kilometers per hour. Okay. Now, other things.
The home location.
Yeah. The last one is home location. This is node bartenders. Is that it?
Yeah.
Very good. What else? Seizing and releasing bartenders. I will select the right-hand side of my flowchart and extend it. And in here, from the same process modeling library, I will insert seize, delay, and release. Very simple, straightforward flowchart.
Note then dragging and dropping the block onto the existing connector does inserts on this block.
Yeah, it breaks the connector and inserts this block in the middle. Just same thing as you have in 8. Okay, seize. First of all, I will rename it to seize BT, meaning seize bartender. The release, same thing, release bartender. And for now, this delay will correspond to customer paying and the bartender accepting the payment for the beer. So I'll rename this to pay. Okay, seize, pay, release, and then drink. Parameters, seize block. We will need to change a bunch of things here. So first of all, resource unit. Obviously, we need to seize the bartender, and just one of them. This is simple. Now, I establish eye contact with the bartender, and then when it's established, the bartender comes to where I am. So I will specify, I will check the box, send seize resources. But not to the agent, not to the customer, because in between the customer and the bartender, there is a bar counter. So I will use more complicated option, which is XYZ. Okay, what's my X? My X is this coordinate, right? This is the exact coordinate of the guest. So here, I will type agent. And then I can do code completion, get X. And then here, Y. Y will be actually a constant. I could choose something like 110, but I will use the coordinate of this counter, so that if I occasionally move the counter, or if I intentionally move the counter, it's the bartender stay behind the counter. So in this seize block, my Y would be counter. Oh, let's leave it that way. Get Y minus 10, because 10 is distance between the bartender and their counter. So this is not correct, right? Because it should be get. So what happens if I compile the model? And by the way, this button is compile without running. Okay, I have an error. So this is error view. If I double click the error, it shows me where the error is, and the method GTE obviously is not found, so I change it to get, and I compile the model again. Good, compiled. All right, let's quickly parameterize the other two blocks. So this is it with the seize block, right? Pay, okay. Pay on average 1 minute to pay. So I simply change units to minutes. 1 minute to pay. Anything else in here?
Maximum
Yeah,
capacity,
of course.
because the capacity will be controlled by the resource pool. Here we specify maximum capacity.
All right, and release. We don't have any other resources in this model, so we release, it's safe to release all seized resources of any pool. However, my bartenders will not return to their home location because the bar is busy. They will stay where they are. All right, we did some changes. Maybe I'm doing something wrong in here with these wires. Okay, so let's run the model. All right, what do we have here? So let's look at 3D. More or less expected behavior. So we have guests coming in, walking away, and some bartenders moving behind the bar counter. Okay, this.
Only 8 bartenders, constantly busy.
Yeah. Very good, very good. And then the next phase is we will introduce the actual beer in our model, and for that I'll ask Nikolay to continue.
Thank you, Andrei. Currently our model operates with almost infinite amount of beer, and to model the beer flow, we will use the fluid library. So here, switch to 200% zoom and add the storage tank markup here in the place where the Corona keg should be located, and name it storage keg Corona. So there will be the animation of our keg with Corona beer, and it will have a height of 20. So now let's add some logic. So we switch to, we go here to where is our flowchart, and we'll add a variable here from the basic elements palette. Name it pint. It will have a value of okay, that magic number, and we can check that this variable will be constant, just for us not to accidentally change the value at runtime. Okay, so let's model the keg. We switch back to the fluid library palette and use this tank block. So it will be named keg Corona, and it will have a capacity of 20 liters. Please notice units, so we obviously change here to liters. The initial amount will be 20 liters as well, and it will have a limited output rate of 0.1 liters per second.
Yeah, this is to model actually the rate at which you fill the glass of beer, as you probably remember from the problem specification.
Yeah, and this logical block will have an animation of the. Sorry, what's happening with the network?
I don't know.
Please note, AnyLogic 9 keeps things returning back after the net.
Yeah,
any
it
network
shows
problems.
remarkable stability.
Yeah. So we select here this storage keg Corona space markup, this one. So I move the right part of the flowchart a little bit to the right and place here a fluid pickup block which will model the actual process of getting the beer and connect these two blocks. So I draw connector from keg Corona tank block to this fluid pickup incoming fluid port. And this fluid pickup block will be named fuel Corona. And the amount of fluid to be picked up will be 1 pint. So I type here pi, press Control space or something like to invoke on completion. So it will be a pint, and the units are obviously liters.
Yeah, it's important to keep the units consistent, of course.
So here we have liters, and all the units in tank are liters per second. So that's it. So let's run the model and see what happens now. So now our model utilizes 3 libraries, both modeling, pedestrian, and fluid. And let's go to full screen and see this is our keg, and it's getting empty now. And you see all these new incoming visitors are getting angry, no beer, waiting. So we need to somehow solve this situation. So we'll return back, and we will model keg replacement. So the easy way to model the replacement of the keg is to create a fluid source which will emit the beer with some small output rate. We drag this fluid source block and name it replace Corona. It will have the rate of 0.1 liters per second, just to model the time the keg gets to be replaced. And the output will be controlled by us by calling this special inject function, and it will have 0 liters initial amount. And we also would like to have this beer be colored in the something with the beer is light yellow. So we switch here to custom badge. We can name the badge Corona. Check this custom badge color button, and this is the badge color property, and we choose here something like light yellow.
Everybody knows Corona colors, so.
Yeah. Okay. So now we have this block with the initial amount of 0, and we go to keg Corona, and we will add an action by clicking this add button in the actions section of the property view. Our action on empty. What we'll do here, we'll inject the amount of the full keg into the replace Corona fluid source block. So we here type replace Corona, invoke on completion, so we refer to that block and ask it to inject 20 liters of beer.
Yeah, it's again, it's important to specify the units because units can be different. The default units, I think, they're cubic meters or something.
Yeah. So let's start the model again. So initially the beer is navy blue. You can also change the initial batch color, and now it's getting refilled. So we receive almost full keg of beer, while the incoming visitors keep draining it. And the atmosphere in the bar is getting better. Fewer angry.
We don't know how many are angry.
Yeah. So let's count them and display some visible, observable data. By the way, I've accidentally clicked this button instead of the full screen mode button. This is a developer panel button, like in AnyLogic 8. You can observe some internal details of the model time, etc. So we currently stop the model, and we will model the beer drinking behavior. So in a usual pub, the visitor often decides to have yet another pint of beer after drinking one. So we'll add a choice block here from the process modeling library. It's select output. We'll name it enough.
Enough.
And by our problem specification, we have a probability of 40%
leaving, 60% staying.
So we type here 0.4 and connect the port of this enough block to the incoming port of C's bartenders. So this will be our returning and ordering one more pint logic. And to model those visitors who get angry, we will use the exit by timeout property of this is bartenders block. So we check here enable exit on timeout, and we will have the timeout of 5 minutes. After waiting 5 minutes, each bar visitor which will will exit the bar getting angry. So we once we checked this option to enable exit on timeout, we can use this upper port. And by the way, I can click this here and here, and create a connector from that port to the exit block. So okay. So now let's
go through, because that was pretty massive amount of modeling that you did. So what you actually did, right? You created this enough block after drinking, right?
Right.
Yeah. Maybe you can go through.
So here we have the choice probability and 2 output ports with the probability of 40%. Visitors go to exit, and with 60% probability they return back via this connector to the C's bartender block, and so they establish yet another eye contact with the bartender, order beer, get the beer, pay, release bartender, drink again, and decide again whether it's enough or not. But in case when all the bartenders are over-occupied and our visitor waits more than 5 minutes, this agent will exit this C's block via this connector directly to the exit, and will exit the bar. And let's set some visual output to our model. We'll switch to analysis palette and drag this pie chart onto the diagram of our model, and by default it already has 2 items. The first one we'll name it happy, and the color will be something green. And the other one will be angry, with obviously something red color. So this pie chart will display the ratio between happy and angry visitors, and regarding the values, we'll utilize the API of our library blocks. So all the library blocks which operate with agents, which have ports, they give us ability to count, to get the number of agents going through the ports.
Yeah, so each block has, in the flowchart, has ports, and each port has an API counting agents or entities or agents that has traveled through the port.
So here we choose the enough block and enough. So it has out
true
port and count function. So here we count these visitors who exit the enough block being happy. And for the angry, we refer to the sys bartenders block. It has out timeout port, and we call here count function as well. So that will be visitors exiting sys block because of timeout exceeded. So that's it. Let's run the model. Okay. By the way, model is running. So I switch to full screen and switch to the virtual time mode for the data to be ready faster. So we can see here that our model has about 20% of angry visitors. This obviously happens because we have not enough bartenders. So let's continue with our experiment.
Yeah. Okay. So the last bit that we want to show you is we want to show you how AnyLogic development environment integrates with AnyLogic Cloud or AnyLogic Model Manager. All right. So just to remind you that we're doing all that in the browser, just press F11. So we're still in the browser, okay? And I want to perform some experiments with this model, which are more complicated, let's say, than just simply animation runs that we use to visually debug the model. So I will add one more item here, which is the output. So in the same analysis palette, we have this output item, and I'll drag it here. I'll name it consumed Corona. And the value, I will take the value of consumed Corona from this Corona keg output outflow, let's say. So keg Corona, I don't remember the exact name of the function, but it's something to do with the amount. So which one? This one, right? Amount passed out, and I guess I need to specify liters, right? Yeah.
Right, because it will return cubic meters by default.
Mm-hmm. Okay, then you may notice that there are options for the outputs. So this one is calculated on the simulation end, and this is exactly what I need. Now, should be it, right?
Right.
Okay, now instead of pressing this run button, I will expand this drop down and I'll choose open experiments. Now, as before, the model is compiled. However, instead of running animation on top of the editor, I proceed to AnyLogic Cloud interface. So what do we have here? We have a new model with one default simulation experiment. And we don't have any outputs because we haven't run simulation experiment. In fact, we have, but we have run it in animation mode, and it does not count for the cloud because in animation mode you can interact with the experiment, therefore its result cannot be, let's say, considered as original.
So let's run it.
Yeah, so let's run animationless experiment. Press this button. You can watch the progress here.
So the model manager operates with the model as like this black box, and here we have a number of bartenders input, which was that parameter, and some outputs, which are going to be to appear now.
Very good. So what do we have here? We have 20% unhappy customers during 5 hours, and all customers consumed almost a ton of Corona. All right. So to answer our question, how many bartenders do we need to keep everyone happy? We will use, of course, variation experiments. So I press new experiment here. I change the type to variation. And here I'll name it vary number bartenders. Okay. So we have another experiment here. Now I will press this gear icon to set up the dashboard. And in the dashboard, I will change the number of bartenders control to range. I will also do some manipulation with the charts. This is not the chart I want. I want actually. We don't care about how many happy customers. We only care about unhappy. So I'll actually delete the chart. Now this one, I will change the type to surface. So I want to see angry versus number of bartenders. This is going to be my chart here. And consumed Corona, same thing. Type surface and consumed Corona depending on the number of bartenders. This is, I guess, it. So varied in range in here and surface charts down there. Save dashboard. Hopefully it's saving.
Okay.
All right. Okay. So I had this couple seconds delay, but looks like my changes went through. And now I don't want to start experiment with 6 bartenders because I already know that 8 bartenders is not enough. So we'll start with 8, and I'll finish, let's say, 12 with step 1. And I'm ready to press my run button to start variation experiment. Now, by the way, why the progress immediately is about 20%? Just because we already ran experiment with 8 bartenders, and the results got stored in the cloud. And the cloud, AnyLogic Cloud, stores all valid results. By valid, I mean corresponding to this current version with that exact parameters. For example, if I change the random seed in my settings, my previous results will not be valid for the new random seed, and I will need to run my experiment again. But in case all parameters match, then these results count. And if I later on, let's say, run another variation from, I don't know, 9 to 16, the first 3 runs will be already there. So my experiment is progressing. I don't know about how about your guys. Hopefully.
And AnyLogic Cloud arranges the individual experiment runs, constituting the whole multiple run experiment to the batches when dispatching them to the computational nodes. And our experiment has quite few number of runs, so they seem to be executed on one node. But if there are numerous runs, they get distributed in parallel. So let's wait. Okay.
All right. Very good. So this chart, this is angry versus number of bartenders. So we see that I guess we need to be on the safe side. We need 11. And with 11 bartenders, the amount of consumed Corona is more than a ton, right? It's 1,100 liters. You may wonder, I mean, why here this curve goes down. I know why, because I did some investigation. This is just because of random nature of the model. All right. Guys, thanks for your patience. I don't know, because I didn't see anything, and I don't know how far did you get on your laptops. I don't know whether it was kind of exciting or frustrating experience, but nevertheless, we're ready to answer any questions, because we still have some, like 10 minutes for questions. Yeah.
First of all, thank you so much. It was very great to experience firsthand AnyLogic 9. I do have a question, and I know it probably has been covered previously, but what would be teamwork look like in AnyLogic 9, like version control as well?
Yeah, of course. So, again, our plans remain the same, and the roadmap and everything. First thing, we need to move all the functionality of 8 to the new stack. Once that is done, the next step is exact teamwork. So teamwork, we plan to integrate with version control system, which is primarily, in my mind, that is Git, although we have some discussions. But maybe Nikolay will answer more deeply that question.
This is subject to our further discussions. For sure, we'll support the simplistic flow like we already have in AnyLogic Cloud, like versions, a straight line of versions, models shared between several developers and users. And regarding Git, I guess we'll introduce connectivity with Git repositories. As I suggest, our users who want to utilize Git, they already have their own Git servers deployed in their infrastructure.
Yeah, and obviously we will need to compare and merge functions, right?
Sure,
how about that?
Yeah. So this comes to our today's morning questions. Yeah, we'll store files in Git in some new format, split to several parts, allowing to better merge different branches together by Git automatically. And we are going to implement some graphical comparison tool inside AnyLogic, allowing our users to compare different branches, observe incoming changes, merge conflicts, resolve merge conflicts, that's it, and so on.
All right, thanks.
Hi, thank you. Do you foresee any of these changes impacting the AnyLogic 8 setup? I know that this is moving into the cloud, but does this impact any of the things with the desktop version?
Of course, AnyLogic 9 and 8 will go in parallel for a while. And with regards to, probably a question is more about how you, as a user, will use 9. So whether that will be a SaaS, our cloud, or installed. So that's an easy question because we understand that many, if not the, well, probably the majority of customers will want software running on-premise. So there will be, of course, on-premise installation of AnyLogic 9. And actually, right, like now you buy and install AnyLogic Cloud or AnyLogic Model Manager. So imagine you do the same thing, but it will include the editor. It will include the model development environment. So basically same thing. So does that answer your question more or less? Thanks.
So regarding the engine and the libraries, so all the libraries and engine, all this computational part of AnyLogic 8 is also used in AnyLogic 9, so it's the same code, one common part of two versions.
Oh yeah. So that is very good for us because engine and the libraries, and that is probably more than half of all code of AnyLogic.
Yeah, and a huge part of editor internals. It's
so that stays the same. So we don't need to recreate it, and you guys don't need to recreate anything. So that part just naturally is shared. Even now, it's shared between the 9 and 8 already.
Hey, Tu. First comment is, I know you said this is going slower than you wanted to, but I think I speak on behalf of this room when I say this is really beautiful to see, and it is wonderful to use this from the browser. So
thank you.
Take your time, keep doing a great job, and thank you for putting the time and effort into
Thanks.
this. I did notice, though, while I was using it, a couple of bugs. So it made me wonder, you know, where do we properly report bugs on stuff like this as we learn them? And where do we actually request features formally? I've always done that through support comments, but is there a canny board? Is there bug tracking anywhere? Are there plans for that?
Well, our bug tracking is not open to public. So please do use standard support channel. These guys are well connected to all of our teams, and they will know where exactly to route your either bug report or feature request. So please stay with our support. They know very well what to do.
So in AnyLogic Cloud, we have this get support features, so something like that will be in AnyLogic editor user interface, allowing you to refer to the model you are developing, for example, if you have specific questions.
Yeah. And by the way, I probably didn't say that, but AnyLogic 9 in its current state, its most current release state, is available to anybody who has subscription active. So it's actually, in a way, open to the public.
Thank you for the workshop. I just want to mention again, I know this came up earlier, but we're very much looking forward to the part where we're going to start integrating AnyLogic with Git and version control. My question about AnyLogic 9 is about the Mac performance. So AnyLogic 8, the performance on Windows and Mac is completely different, and I actually had to get a Windows machine. So is the performance on AnyLogic 9 is going to be similar, or what should we expect?
Oh,
Thank you.
thanks. It's going to be the same. Just, I mean, that problem, that difference immediately goes away because just reminding you that that all happens in the browser. We're using the browser engine in browser, and HTML, SVG, all this sort of stuff is super performing these days and improving all the time. So, and that there's no difference between Mac and Windows. So no, there will be no difference at all.
All right, thank you, Andrei, Nikolay. Awesome job. Please give it up for him.
Guys.
Thank you.